Hi everyone. So in this lecture, I'm going to discuss about service mesh. So if you just to go back, so this is your Kubernetes cluster. There is a control plane, which runs the manage. It's the basically it's managed by either like an external vendor or external service provider, and then this is your group worker group. Uh, Node group where you will be running workers, and in this if you see each worker will run pods. Now why do you need a service mesh? Normally in a cluster you will have ingress, right? And then if you're anybody from outside can access your service using the load balancer, which will directly hit the ingress endpoint, and then ingress has the details of each service endpoint, and it will reach the using the labels, then the service can directly reach the pod. That's normal, but and this is called north south traffic, right? But the requirement and use case of using a service mesh has been growing ever since, with new products coming in, because service mesh allows you more security and also service discovery. Plus within multi-cluster it allows east-west traffic, which means if uh, this service wants to talk to another service, it's the service mesh comes into picture. It's basically it's kind of a pattern which will implement like more security, and it uses modern networking and connectivity and between the microservices. It's very popular in context of only microservices. And normally there are many products out there for this, like Istio and Kong and Solo. So but the high level architecture is because it provides security, right? TLS. So and normally there will be a control plane running the for the service mesh itself. Now this can be either in on-prem, or it can also be SaaS. And then and norm but normal architecture is using so this green box represents a sidecar proxy. So it has to be, because the on the worker node where your pod is running, the pod has one container, right? But there will be another one running, which will be using the injection sidecar injection, and this will be the data plane sidecar proxy. So every pod will have another sidecar container running. So that is the current architecture, like a lot of these products are using. And so this is called the data plane, and this is called the control plane for the service mesh itself. So if you see, let's go, like for example, let's talk about Kong, right? So what is Kong? Kong is basically there is a free, not a free, like open source product, which came from CNCF. It's called Kuma. So this Kong mesh is basically high, like enterprise grade level service mesh architecture service that is built on top of Kuma, and also it uses Envoy. If you've heard ENVOY, Envoy for similar uh, architecture, similar technology. So it uses Kuma for the control plane and Envoy for the data plane. So Envoy proxies have been around, Istio and Envoy have been around for a while. But the benefit is that it's basically it provides security, it provides reliability of networking and traffic, and also it has a lot of multi-cluster across cluster traffic management, and it provides a lot of service discovery out of the box, so you don't have to worry about it. But the architecture, how high level, if you see in this diagram, it's coming from the I have pasted the link. It's actually coming from Kong itself, and you can go and check more if you want to. But if it's as this clearly shows, there is a control plane, which is a Kuma control plane, right? And every service will have a data plane, which is like your sidecar proxy, which will be how it will detect, that which is a new service. Whenever there is a service running, like there is a how like service discovery is as part of this data plane itself. So this DP is the data proxy and CP is the control plane. So there is this architecture, if you see, right, it is made up of sidecars. Now the sidecar proxies are deployed in as part of your pod or your service, right? Now this is basically for any Kubernetes service, you have to make sure that the deployment has the right injection, like it is a it's a like it is a annotation and a label that is required to inject, so that when the when your pod comes up, automatically a sidecar container will be injected as part of the startup. So that is the um, basic thing. And then let me show you the little bit on the, so if you see the uh, so this is basically this is my sample YAML. If you can see, this annotation is required. It's coming from Kuma, and then there's a label which is important, is called sidecar injection enabled. So basically that's how it will inject itself into the pod. So if you go back to the architecture back here, right? So now, what is the now when we are using sidecar proxies, lot of there have been a lot of like issues, because definitely your this is itself a container. It will also use CPU and memory resources along with your container, along with your service. Plus, there have been some, there can be complications. So, if there is a way to have a architecture without a sidecar, that's where some of the latest developments and research has been going on. So if you look at this architecture diagram, there are a lot of benefits of using service mesh and a sidecar proxy. So one of the important things is, as you see, every service has a NY proxy or a data plane. So all incoming and outgoing requests from the service will go through a local sidecar. This is a data plane or your process. Now, because and this will be basically, it will provide TLS. It will provide critical like security, routing, caching. Everything will be delegated, so all your applications don't need to really have that piece of code. Everything can be delegated onto the sidecar. And also and the data, and then if you see the control plane, right, all these two data planes, they do communicate with the control plane. And then after proper setting up an authentication, and this maintains like a holistic view of the whole cluster. And then this also can provide you with all the data that you need, like related to traffic and incoming and outgoing requests and all that. So this kind of provides a lot of good features. But lot of the another thing is using, it depends on what your requirements are, but sometimes a lot of teams opt for sidecarless. So what is sidecarless means? Now, why would, like, a sidecar pattern has a lot of advantages, but sometimes it comes with additional configurations, like you have to have the in every pod and namespace, you have to have the sidecar injection. And of course it will use CPU and memory if those sidecar containers, and if there is a change in the, or there is a new release on the sidecar, then you will have to definitely restart your pod. And sometimes debugging can be difficult in a Kubernetes cluster with multiple services. So then there have been efforts started, a couple of years ago, to use sidecarless, service mesh. And there are two great products which are still, there were a lot of things covered in KubeCon on the same. So if you can go to YouTube and Google for KubeCon Sidecarless or Istio, and you will see some sessions. But I have pasted two links. They talk about, this is basically Istio Ambient architecture, and then other one is Cilium. So Cilium is basically, they all use different latest technologies, not sidecar pattern, but some of them use eBPF. And these, because to avoid the challenges of performance and network policies and all that, the Cilium service mesh is the latest one. And the other one is the so Istio has been around for a while, but it's called Istio Ambient Mesh. If you click on that link, it's called Istio Ambient Mesh. It's from Solo is the company. And then basically you can also migrate your existing sidecars to the Ambient Mesh. So it's kind of a mode. Maybe you can call it an ambient mode. It's basically fundamentally changing how service meshes are implemented and managed by removing the whole piece that was causing. So there are some things that can be explored, and then a lot of work is still continuing on this.